Welcome to the inaugural meeting of Contract Book Club. So basically, it's like a book club, except for Solidity contracts and protocols. The scope of what we can discuss can change, but for right now, it's Solidity contracts. And it's really exciting because I feel like this hasn't been done in the past. Like it doesn't exist with open source projects or whatever. This notion of like a coding book club has never existed before, or as far as I know. And I think the reason that it can exist now and that it's really special is that a lot of these companies and projects are open sourcing their secret sauce. It's if Uber were to open source its dispatch code that connected writers and drivers, but it doesn't do that because that doesn't happen in Web 2. But right now, we can literally read through Compound's protocol code and do whatever we want with it. We can fork it. We basically have access to all of their secret sauce, which is really cool. So the typical timeline, it's 2 weeks. And everything I say right now, of course, this is the first meeting. So every time we have a session, we're going to talk about what went well, what didn't go well. We're going to take feedback from everybody and just continually iterate to make sure that it's productive for everybody and interesting for everybody. So right now it's 2 week periods and there's a guide chosen for every week. The guide will pick the protocol and that makes it really, fun if you get to choose what you're presenting. So the guide will come up with the protocol to discuss and their plan around how to discuss it. And during each session, the next guide will be chosen or folks will be able to volunteer. And there's a list of topics that I pasted in the chat if you don't know what you want to present, but you want to, or you can come up with your own. And so the guide will pick a topic and then we decided, and I'll paste all of this, but we decided that the Friday of that week, they'll announce the topic and some reading material. So the guide has some time to collect these resources and then post them to the group. And we'll read as much as we can. There will be a mid-week or mid-2-week check-in where the guide will post some questions just so you know that as a way for each of us to know whether we've done enough reading. It's like a pace tracker, like when Anthony in Shipyard says, at this point in the course, you should have A, B, C. So just a way for you to check in on yourself. And then at the end of the 2 weeks, the guide will lead a full session through the protocol. It's a program that they design and we'll all talk about it. And the cool thing is we'll all have done hopefully our own research into how a particular protocol works. So when we come together to talk about it, the discussion can go pretty deep. And the ideal outcome is that we all know a little bit more at the end of each session. There's some other ideas we have that will continue to develop as we go on. I think that a lot of learnings will come out of every single one of these meetings, and it would be great if we could share. I know I'll be taking notes for this meeting, but we could even give back to the greater Web3 community by sharing the things that we discussed in every call. And then one thing that Melville mentioned in the chat is we are looking for a guide for the next session. So if you're interested, you can volunteer now at the end of the session or just hang back if you're interested, and we'll talk about how to get you set up for that. And that's pretty much it. Does anyone have any questions before I hand it off to Melville?
Just one add to that for the guide. We're still playing around with this, but I know that Harsh, who's helping us along with this, Harsh definitely was up for some sort of payment or reward or bounty or something for people who are guides and people who produce content. And just from what I've done just for preparing for this, I scoured the internet looking for this particular set of code that I'm going to walk us through today. And just from creating that's valuable and that's worth rewarding. So if a bounty would help you to be a guide, we can definitely talk about that. I'm going to share my screen and I'm going to show you a brief look at my intended plan for the next hour and a half or so. So just had our kickoff and intro. I really think just for the future, showing people the subgraph and showing how easy it is and how powerful it is would be useful for everyone here in future cycles. I want to start with a graphical intuition behind Compound. And this is the reason I chose Compound is debt never made sense to me on the blockchain, particularly with it being over collateralized. So for me, this part right here was like the click that made me realize, oh, this is what it's useful for. And we'll walk through some graphs and some examples. Then we'll take a 10-minute break and spend the rest of it looking at code. And in particular, we're going to look at a example of shorting Uni. Uni is the ERC20 token for Uniswap's governance. And we'll touch on things like supplying liquidity, borrowing liquidity, changes in price. We won't get to liquidation here, and that's the plan. And I definitely want to say this is going to feel lecturing, and maybe it feels more so because I have often lectured to some of you, but I really think the best way this is going to work, and I'm going to try to elicit this out of people, is while we're going along the way, we'll look at certain functions and certain parameters, and I'm going to be asking y'all to, what is this thing? And I know I have a lot of questions myself, so we may get derailed, and that's totally okay. If we don't even finish going through this code, but we're going off on tangents, trying to explain something about a particular parameter, that is perfect for me. That is what I hope will happen. All right, so let's start off with a compound subgraph. We talked a little bit about this in the immersive 6-week program. Subgraph is this tool for off-chain indexing, and Subgraph has made it really easy for Compound, Uniswap, whatever protocol to go in and index data and make it easily queryable for everyone, folks like us, to go and figure out what's interesting in this system. And usually when you go, they'll have a pre-filled query that you can go and click on, and you can see it here. So this is getting us the first 7 markets, which are just the C tokens. And then it's showing a bunch of parameters. And usually these map one-to-one with storage variables on the contract itself. But they don't always. And that's the beautiful thing, is you can derive richer data from these subgraphs. So let me show you. For some reason, it is not straightforward for me to find good GraphQL query examples, but I did eventually figure out how to do a where clause here. So if I want to get the C token, or they call it market here, for CUni, then I can just do a where clause on the symbol. And we can look at interesting information here. The borrow rate, how much cash, this is in USDC, collateral factor. Anyone want to explain collateral factor for me? What's 75% mean?
Like for every dollar worth you deposit, you can borrow 75 cents of another token.
Yeah, that's what I was going to assume.
So my understanding of this was that, and even for something like really, I don't know, stable-ish, like ETH, it was still, I think, 82.5% for ETH. But like, why is the reason they don't just make it 95 is that a liquidate might not be able to come in by the time the value of the borrows outweighs the collateral? Or is there another reason to keep it much lower than?
Yeah, it certainly needs to be lower than 100. And I think that what you said makes perfect sense to me. It's like the closer it is to 100, the more plausible it is for the sort of system to become under collateralized. And so this is just defensive towards that. I was curious where they picked some of these numbers from. And I don't know, along the lines of what you said, maybe it's mostly related to the perceived volatility of the asset.
I think that this factor is a thing basically. So the ETH basically is more safer than Uni if they have to liquidate, right? So I think that's why they come up with this number. So if there is some other, say, not well-known token, I guess it will be even lower than that.
What was a low one I saw? I think Sushi was in like the 30% or 20%.
Yeah. What about like USDC? Is that going to be very stable?
Yeah, let's try that. CUSDC. Wow, it's still 8.
You have faith in the US dollar.
Bunch of gold bugs and Bitcoin bugs. That doesn't make any sense to me.
I think there is also a liquidation fee. I think that's like maybe 10% or something like that.
Oh, yeah. So actually, we can go and check that right now. And if we do, what I like to do with these, because there's not like a scratch pad, but you can copy these out or comment, and then we can look up controllers. First, you want to see just like how many controllers do we have? I think we just have 1. And then so we can look up the close factor liquidation incentive. Let's max assets too. So one thing that really slowed me down and was painful was just trying to figure out, like, when are the units 18 decimals? When are they 8 decimals? And then you have to worry about the individual ERC 20 decimals. Decimals was just a horrible decision. We had never done that.
And so I think they keep converting between those. If you
Oh yeah, close factor, it's 0.5, and
We need a
It
Chrome
should be
extension that's a little
8%.
button that just hunts for long numbers and injects commas in there for you.
yeah, that would be nice. And then liquidation said it's 8%. And I don't know what 20 means.
I think that's the
That seems
most.
very
That's
low.
the most assets that you can either borrow or deposit. I'm gonna guess borrow at a time per user.
Uni and USDC and etc.
And I'm guessing that they have that limitation because when they're trying to calculate what a user's liquidity is or whether they're eligible for liquidation, they have to iterate through all of their markets.
Yeah, that's when I was working on the options protocol, we had the same problem. I'm glad you brought that up because it answers another question, which is why were they having to have a list, and like, why did they have to have that enter markets call? We'll look at that in a little bit, but it makes sense. They can't just allow any asset because it'll eventually grow unbounded and then there won't be enough gas in the block to calculate the hypothetical liquidity. This is just a safety parameter. Yeah, so I think just the takeaway for the reason I brought this up in the first place was this is from now on with the next protocol we do, this is the first place I'm going because it gives you a high level, clear, concise overview of what are the important just words in this system. Collateral factor, exchange
Is
rate.
it safe to assume that whatever next protocol we pick would be indexed?
Yeah, I think that's safe. Might not be true, but it's just so easy to write subgraphs that there's really no reason not to. Oh, one more one that I never sent out, but I'm just remembering now. For anyone who hasn't heard of it, Dune.com, these Dune analytics are great dashboards. Oh man, I managed to pick the one that's like kind of black. But usually there's like, you see graphs here. Okay, this is actually a different protocol. But anyway, if you go to Dune.com, this is another good one to check out in the beginning when you're just trying to dive into a protocol. And it'll give you the kind of high level, just what's important here. And I definitely don't understand everything here, but I do understand that assets under management is probably something that's important. Any more topics of conversation people want to do with Subgraph before I jump on to some more graphical stuff?
Is there any information
Actually-
like transactions in the Subgraph?
So we can go to transfer event. Oh, here. Yeah, this is more like low level, like almost
This is-
debug stuff.
This logs for the indexer, right? Or is it logs
Right.
that were emitted by?
Nope, this is exactly the first one. There is this piece of software right here. You can download and run yourself. It's actually quite easy. And you will see logs like this.
Maybe one more thing is all the errors or failures are sent into a separate event. I thought like that was interesting
Yeah.
because
Do
I
we-
haven't seen
do
that
we-
model anywhere.
Yeah, I hadn't either. Let's save that though, because I don't see any of the errors here. And in the code, I have a part where I also want to talk about the errors, but it's easier when they're right in front of us. I actually have one last question. This interest rate model, I didn't have time to look in depth in this. Did anyone figure out why there were different interest rate models and how they differ?
As far as I could tell, there weren't really many different models. They all seem to kind of inherit from the same place. And it was all just this, it has a certain slope up to a point, and then there's a kink at which point the slope gets higher. And so the borrow rate increases after some sort of percentage of allocation of the market. I think there was a different contract for DAI specifically. I looked at it and there was a bunch of stuff in there that didn't make sense to me, but that seemed to be the only one that like actually had something different.
Gotcha.
Is that something that governance can set?
I think so. Yeah. When you initiate the new market, I think we have to specify the rate model.
If so, it sounds like an interesting kind of thought they had about, oh, maybe in the future we want to have different ones or for different currencies. I guess they use it for DAI. It's an interesting idea, but probably the majority of the time you find one interest rate model that works and just run with it because people aren't going to nitpick that part of it a bunch, apparently.
It implies that they don't have like a golden relationship like Uniswap has with the constant product module, constant product formula. And instead, it's a little bit more, let's throw stuff at the wall and see what happens, which is interesting.
DAI is the one that's unique, and it actually seems like it depends on, I guess, the DAI savings rate. I'm not sure what that is, but maybe if you hold DAI, then I don't know. But the others didn't seem to depend on anything external like that.
Let's jump to the errors while we're here. I was not sure, but I thought the reason they might want this is they wanted a model Go where Go always returns tuples which are an error and then the actual object, and you're intended to check the error. So maybe they were influenced by Go. Or I couldn't really figure this out. Was there a reason why they wouldn't want it to fail? Because they return an error and the object as opposed to throwing. Where would that be useful?
I'm guessing mostly for user interface. So because you get the proper object and you can inspect it and display the UI, what it means, right? Otherwise, because that's what I remember when we were doing the project. It was difficult to get the exit revert reason from the Solidity code when you catch the exception in the JavaScript.
That makes sense. Great. That was perfect. Thank you, folks. I went over, I said I was going to do 5 minutes, and we went over talking about things. This is going super well. So I'm going to talk about this because it seems pretty basic and fundamental, but it definitely was not for me when I first started. And this was the gotcha moment. And before jumping into code, I think it makes more sense to get a high-level graphical intuition for what's going on, because it allows you to figure out a lot of the kind of deep parts, I think, of Compound that were not apparent to me until I started going through this. So all the future graphs are going to be like this, where it's a profit and loss graph. So green up here means we're making money. Red down here means we're losing money. And on the x-axis is price of the underlying. And for the most part, this will be ETH, but we do a uni example later. This one is the super basic. This isn't even related to Compound. This is just, if you hold ETH and the price is $3,000 and then you have 1 ETH and then it goes up to $4,000, then you're going to make $1,000. And life is great. I think it's pretty straightforward. Similarly, you're going to lose $1,000 if it goes from 3,000 to 2,000. And I think we're all pretty familiar with this. And just one property that's maybe even so obvious, not worth pointing out, but the returns are linear and they're symmetric. So if you've ever done like options trading or anything with options, the options have this non-symmetric payoff where usually they either put you in the red, but then steadily have infinite upside as the price increases, or the mirror of that. This is the key graph for me. What this is saying is in the shaded out line here, or arrow here, this is the original one we looked at before, which is just your returns if you simply hold ETH and the price goes up or price goes down. This one right here is what happens when you use Compound to create a leveraged position in ETH. And the way I think about it is just graphically, what it's doing is rotating, or it's making the slope of your profit curve steeper, which is great if things go really well and the price goes up, but it's equally not great if the price goes down. And I guess you would want to use this when you're in a position where you're very certain that the price is going to move one way and you want to try to make as much money as possible. And I finally understood by reading about Compound that this is how you do it. So I want to walk through an example right here. Is anyone else here like amazed at finally reading this and finally understanding, oh my God, this is how leverage works? It was a great feeling for me. Like I knew it, but just again, this is a good reason to be a guide. Do you really have to think through this because you need to explain it to other people? You guys will be the judge. Maybe I'm full of crap and don't know what I'm talking about. All right, so I want to walk you through an example of how you actually set up this leveraging. So let's give some context. So price is 3,000. We're looking at ETH in units of USDC. We've got 1 ETH. So our total value is just the price of ETH times 1, 3,000. And then I looked up the collateral factor for ETH, and it's pretty high. It's 82.5%. But when we borrow, we don't want to put it at 82.5%. For instance, if we put down 1 ETH as collateral, we don't want to then go and borrow 82.5 USDC. We actually want to borrow a bit less. If that's not clear for anyone, does someone else want to explain why?
If you borrow at 82.5 and the price goes down $1, you're gonna get liquidated.
And if the price goes down $1, you'll get liquidated. And actually, even if the price stays the same, after several blocks, you'll get liquidated as well, because one of the fundamental parts of compound is when you borrow, you owe interest. And that interest...
I'm not sure that's true, because you actually earn interest on what you're supplying. And because you've supplied more than you borrowed, I suspect that you're actually earning more interest on your supply than your borrow. I don't think you'll get liquidated. Sorry.
No, please, like, this is perfect.
I'm not sure you get liquidated just because of time. I think you would need the price to go down, unless the sort of interest rates between the two, the collateral versus the borrow, were different enough to make up for it.
Isn't the borrow rate like much higher?
Yeah. Generally, borrow rate is much higher than.
Got it. Okay. I didn't realize that.
So the example I had in my head is, what's the value here? If I had 1 ETH and then I tried to take out 82.5% of that in USDC, eventually I would need, so what would that end up being? Let's do some math. 1,000 times 0.825. So if I borrowed this much USDC, 100 blocks later or 1,000 blocks later, 245 plus epsilon, like some amount, let's just say 10. That would put me over the limit, which would then allow liquidation function calls to succeed. When it's below that ratio, any attempt to liquidate will fail. Yeah, that was my understanding. I also got that from looking at that smart contract program YouTube video with Liquidate, because the way he did it was he just advanced the block 1,000 blocks ahead, and then that made the position eligible to be liquidated.
Well, yeah, I just looked at the numbers. I was totally wrong. There is definitely a big gap between the sort of supply and borrow APR.
Cool. Thanks for calling me out when you think I'm full of crap.
Hey, just to point something out, there was a moment where I'll be meeting you for the first time. You apologize for calling out something that might be pointing out a flaw in what Melville said. And I thought that was actually super healthy, because we're all here. Like, Melville's not necessarily the lecturer. Like, we're here to learn together. So he's learning it too at the same time. He just spent a lot of time prepping for our session today. So please keep doing that if you see a discrepancy.
Yeah, 100%. Honestly, you sound more than I do. So we're going through this example, and remember the goal here is we want to show how do we actually create a leveraged position. And this isn't just a blockchain thing. This is like how trillions of dollars of debt markets work. So it's kind of learning how physics works. It's a pretty fundamental part of how the world functions. So we're up here, we got our 3,000 total value, and less than the collateral factor, which is 82.5. So I just arbitrarily picked 70%. So we're going to calculate how much can we borrow. And that's going to be our total amount of collateral times something a little bit less than the collateral factor, which I put it again, 70%. So I did that math, and it came out to 2,100 USDC. So that's the amount we're going to borrow. So we borrow it. And then what we do is we immediately go and we purchase ETH with it. So we swap in Uniswap, we give it USDC, and it gives us back ETH. Just doing the math here, if we have $3,000 worth of ETH and we pay $2,100, that's going to give us 0.7 ETH. Throughout all this, I'm ignoring fees, and I'm also ignoring borrow rates and supply rates just to make things simple. But basically everything would be lessened because of gas costs, needing to pay back the interest. But just a spherical cow example. So now we have 1.7 ETH. 0.7 of it is actual ETH, and 1 of it is locked in compound, and we own the C token, which is like the LP token, the liquidity token that we can use to redeem it later on. Can we redeem it now? At this point, could we redeem the C token? I don't think we could, because then our borrow would be under collateralized. One want to correct me or show me the light?
You could withdraw ETH up to your collateral factor, but not more.
Yeah, that makes sense. So at this point, we can see where this is going to go. Instead of just 1 ETH, we have 1.7 ETH. So any changes in the underlying price are going to magnify the profit we would get, opposed to as compared to just holding the 1 ETH itself. It's also going to magnify our losses. So let's imagine that the price goes up $1,000. We still owe this 2,100 USDC, but now we have 1.7 times the price of ETH, which it went up $1,000, so it's 4,000. So now we have $6,800 value worth of ETH. So we can take $2,100. We can take whatever the equivalent amount of that ETH is that's worth $2,100. We can swap it back on Uniswap and then repay the USDC that we borrowed up here, which is going to bring our position back to, we don't have any liabilities, we don't owe anyone, we just have the ETH that we started with. And what it comes out to in profit is $1,700 of profit, as opposed to $1,000 if we had just held ETH. And then you don't even really need to do the calculation, because you can just look at this graph and see that the slope doesn't change. There's not like a kink in it. So you know that if the price had gone down similarly by 1,000, then we would be in the negative 1,700, which is worse than if we had just held ETH.
I think in that scenario, you will also get liquidated.
Yeah, I think you would get liquidated. You would get liquidated whenever the value, when you get up to your collateral factor. Can we talk about that? One thing I didn't understand about liquidating, because that one I looked into the least, is what are you actually doing when you liquidate someone? Like, what accounting variables are being up?
I think my understanding is you pay back the loan that they have, and then you can withdraw their collateral. In this case, you would pay back the USDC.
Since the close factor is 50%, you would close half of this.
50.
So
Yeah.
it would be 1,050. But then how do you calculate how much collateral you take?
You get $1,050 worth of ETH plus the incentive. So like the liquidation incentive is like 1.08. So I think you would get 1,050 times $1.08 worth of ETH.
That makes sense. But then it opens up another question for me. Help me understand the percentages and kind of the ratios here. If you pay back this much USDC and then you take that equivalent amount of collateral plus the 8%, aren't they still under collateralized? And won't they just immediately get liquidated again and again until there's nothing left? What is it about liquidating 50% that makes the system healthy again?
Is this in the context of them withdrawing or getting liquidated?
Getting liquidated. Yeah, I do not understand the liquidation.
So what would happen first is the price would drop, right? So whatever asset they're collateralizing with, the external price would drop such that now it's worth 50% of what it was when they originally deposited. And once it gets to the 50% plus the liquidation fee that the protocol takes, they're going to cut it. And so we'll just transfer ownership from the person who collateralized, who's going to keep the loan money that they haven't repaid, but they're going to take the collateral that the person deposited.
And then it's not collateral factor, but I don't know the right word, but what is their ratio going to be at then between collateral and their borrow?
So they will own whatever borrowed money they haven't spent. That doesn't get reclaimed by the protocol. It's the collateral that's reclaimed. So technically, the protocol is still getting 100% of the assets because it's a one-to-one swap depending on the collateralization ratio. So the person, let's say they borrow 100K and they deposit 150K.
Let me just write this down. So deposit 150, borrow 100.
And then let's say that, again, this ratio is different, I think, than compound, but whatever, it's easier to understand. Let's say that the market value of the deposited tokens goes down to 100. They're going to liquidate. Ideally, it's going to be higher so they can take the incentive fee. So maybe it'll be like 108 for the 8%. But then the protocol will keep the deposited amount. And that's why you always see protocols with a minimum 100% collateralization ratio, is because they need to account for the market volatility of the asset they're putting in. So because ETH will go from, I don't know, 1,500 to 3,000, they need to have a 50% buffer.
So that kind of implies that when we have things like L2, which are going to increase the number of transactions that can be put through and ideally reduce blockages like network, that you can then raise the collateral factor because it'll be ideally as quickly as you can push electrons through a wire that
Correct.
the liquidations would come in.
I guess there's two things for that. One, if you have a faster system, that means that it's more liquid, which means that it's going to be more volatile, which means that your collateralization ratio is going to have to be higher because people are just trading a bunch of shit. But it also means that the transactions can be settled, which means that the price difference at any given second will hopefully be smaller. But also, what if somebody does a massive market sell-off or market buy, then the price jumps up? So there's a lot of stuff, but theoretically, it'll be more volatile.
Cool. Before I move off this, I just want to vocalize what you helped me realize. So if we look right here at the ratio between the, let's not call it deposit, but rather collateral and borrow. And this is just, doesn't matter the units of this, it's just like value. So let's just say it's USDC. Usually these would be in different tokens. But here the ratio is 3 to 2. 50 divided by 100 equal. And now when the price drops down and it gets liquidated, and like you said, 50 gets clawed away and it gets clawed away equally from each of these. So it's going to be collateral, it's going to go to 100, and borrow, it's going to go to 50. Now the ratio is 2 to 1. And I probably have to invert these. Here's the main takeaway. The system got safer because this ratio got smaller. Or I guess you could say it the other way. The ratio of collateral to borrow got larger.
The collateral in this case would drop by more than 50 because of the liquidation incentive. The person is paying 50 as a borrow token, they're getting something like that.
Yeah, so like the protocol would factor into the collateralization ratio. They'd add a little premium on it. If this drops below 58%, cut it. But yeah, they would attempt to keep that on top, clawing back all of the collateralized funds.
So you are saying the liquidation will begin around at 108, not at 100.
Yeah, exactly. I was the protocol and I was liquidating. I would still want to get paid for the risk of holding those assets in the first place, which is the 8%. Does that make sense?
Yeah, just to me.
Do we take the 8% from the 50 claw away, or do we claw 50 away and then add 8%?
Yeah, that's what there is. I think in case of compounded, I think it's earlier. So it won't wait, protocol won't wait until 100 price to drop or collateral value to drop to 100. It will somewhere around 108. It will say these things need to be liquidated. And who does the liquidation? They get the 8% value.
That's correct.
So then this would be awesome. That was probably the biggest unknown for me right there. So thank you, folks. All right. I want us to take a break. And so I will just reveal this all at once. And if you want, this is recorded and we'll share this so you can go back and calculate it yourself. But another really big realization for me was the ability, like how shorting actually works. And to be honest, I've never understood mechanically how this works. And finally, I understood it because I had to walk through this bit by bit. But the basic idea is you do the opposite of what you do when you leverage. If you think about what we did when we leveraged, we used ETH as the collateral and we borrowed USDC, which allowed us to buy more ETH. But when we short, we're going to use USDC as the collateral and use it to borrow ETH, which we're going to sell to get more USDC. because the idea is when we short, we profit when the price goes down. And the idea is that if the price goes down and we owe Ether, then we can just buy that Ether for cheap now that the price has gone down and repay it. And so if you've ever heard the explanation, which I've heard all the time, short selling is like when you borrow the money and then pay it back later, which never made any sense to me because it seemed like people were just sitting there, just shoveling money out to you, waiting to be short sold. Now it makes a lot of sense because in a system like Compound, you don't ever really have to pay it back. You just always have to remain under the collateral factor. So as long as that price keeps going down, remain under the collateral factor and you'll be making those fat stacks. All right. For anyone who wants to, later on, I put a little like walkthrough that we could do here. And I thought maybe we'd have some time to have one of us walk through and solve it for the leveraged uni example. And you can use the context here, but I think we should take a 10-minute break and then we'll switch over to looking at some code. Come on back. And I actually have one last thing I forgot I wanted to mention about this. I also hadn't realized before, but this helped me understand. So the example we showed over here with the leveraging applies to the shorting, because shorting is just like the reverse of it, or the inverse or mirror of it. But is there a way that I could leverage even more with still the same amount of ETH, just one ETH?
Yeah, you can.
Yeah, you can go to the second loop of the borrowing.
So the first time I got 0.7 out of one of ETH. So it'd be like one times 0.7, which is itself, times 0.7, and that'll be
0.49.
around 0.5, and then I can even do that again. And I'll try to figure out, so where does it, one, is there like a closed form equation for solving for this? And I guess involved in that answer would be like, where does it bottom out? When does it finally stop? Because isn't there some mathematical equation where you have 0.5, like the harmonic series, which is 0.5 plus half 0.5 plus a fourth of 0.5. That is an infinite series that doesn't diverge. It adds up to 2. But isn't there a mathematical formula for when that number is greater, when that ratio is greater than a half, doesn't it diverge? Or do I have that wrong?
I think if it's less than 1, it should converge. I think just intuitively, I don't actually know if that's true.
Yeah, we should check that. Does anyone know is a closed form solution for this? Like basically given a collateral factor, how much can I pump this baby up? So I'm going to move away from the graphy stuff and let's look at some code. I think this will work, but let's see. So the example I want to show is this shorting example. So this is going to correspond to this graph right here, where we want the price of ETH to go down, which is going to allow us to profit. And the idea behind this is that we're going to start with USDC. We're going to borrow uni. Then we're going to sell that uni on Uniswap for more USDC. So we owe uni, and we're hoping that the price will go down, which it will, because we're gods and goddesses, and we control it through the magic of mainnet forking. So we'll get the price to go down, and then we're going to buy back the uni we need, but it's going to cost us less because, again, the price went down. And then we're going to repay the uni and profit. I want to be very honest because I feel proud. I spent pretty much all day today getting this working, and there were so many little gotchas and things where just stuff didn't make sense, and it was a great exercise for learning how to do mainnet forking. Ooh, actually, I think some folks here from the previous block, we realized we didn't talk about mainnet forking, so we added that into the new block. And Bradley, I think you've seen it. Can someone who has not heard of mainnet forking please raise their hand through the reactions on Zoom? So I have an excuse to talk about mainnet forking?
I don't have that, but actually I don't have experience, but I'll also give you another excuse. A lot of the job interview problems that we've seen recently have been this like mainnet forking style. And then we also received it as feedback from one of the engineers that works in Web3 right now as like a improvement point for the class. So it's definitely something that comes up often. And like Melville mentioned, we're adding it to the curriculum for the next block.
Great. Okay, thank you. Also, Aaron, thank you. So mainnet forking is really interesting because unlike Web 2 world where basically everything's too complex and there's no way to predict what's going to happen, anyone who's made a big deploy on, God forbid, a Friday knows a little bit what I'm talking about. But that's not true in EVM land. The EVM is deterministic. And we have all the state available to us. So we can basically simulate transactions, and not only simulate transactions, but also impersonate other accounts on the system. And you can go look up in the hard hat docs for how to do this, but it's really easy. You add this hard hat section to the networks in your hard hat config. The chain ID doesn't really matter. All that really matters is this, where you provide a URL. And I got this URL from Alchemy. And then you pinpoint it to a block number. If you don't do this, then it's just going to use whatever the most recent block is, which isn't very useful because when you mainnet fork, you want to keep the state the same so that you can write reliable simulations and you don't just have the reserve factors of Uniswap changing out from under you. So I chose an arbitrary block, somewhat recent, maybe a couple days ago. And now whenever I spin up my hard hat tests, they're going to use actual mainnet state. And oh, by the way, you may need to add this as well. I found this to be true because as part of this forking, I wanted to use the USDC contracts. I wanted to use the USDC contracts because in this function, I wanted to pretty much become the master minter of USDC and mint arbitrary amounts of USDC to people. So in this function, the key line is I'm using this built-in hard hat RPC command. This is not part of the normal Geth RPC commands, but it is of hard hat, where I can impersonate an EOA. And then as that EOA, I think under the hood, it basically sidesteps all of the private key signer generation stuff. And it just says, yes, valid signature. And with that, I can gain control of the USDC protocol. And in the end, I can mint arbitrary amounts of USDC to arbitrary addresses. So if you're like a black hat and you're trying to hack some protocol, this is essential. And if you're just a regular smart contract and you're trying to understand if your system is going to, for instance, upgrade correctly with this new upgrade process you have, or maybe you're trying to do an important admin interaction, you can simulate it using mainnet forking. So that's what I'm doing here. And what it means at a high level is I'm going to interact with the mainnet version of Uniswap and the mainnet version of...
This is super impressive, first of all. This is amazing that you did this in the last couple of days. And just to clarify what mainnet forking is, it's literally those configuration parameters in the hard hat config file. That is mainnet forking.
Exactly.
To reiterate, to avoid the like hair on fire situation from Friday deploys, the suggested way to deploy a contract is first you run a bunch of tests against a mainnet fork. And then when you deploy, it's going to work because it's deterministic. And what you test locally is actually what's going to happen when you deploy.
So I said lie because it's simpler, and I'll tweak it now because the Jungian model, but it's a little bit of a lie because of this parameter right here. So if you test at even the block right before the most recent block, and then you like immediately go and scramble and enter in your multi-sig signatures and execute the upgrade, there's still some block difference. So there's likely some state change. And this really only matters if you're interacting with Uniswap or trying to do a flash loan attack or something where from block to block, state is volatile. But for the most part, this is such a leap and bound above just like Hail Mary, worked on my local machine, let's do it. that
Also,
is
of
indispensable.
course, the other element of determinism, which is the mempool and front running, and you're not including all the bots that might try to.
Oh, super good point.
Say that again, Kyle. I didn't follow.
In reality, like you get to run your transaction, you're not competing against other people with competing interests, but because there's MEV,
Right.
your transaction might be front run or whatever. That's technically another reason that the determinism is a bit deceitful here. It is assuming you have honest miners.
This is the logic for minting arbitrary amounts of USDC. And I went through, so the tokens we're going to use here are USDC and Uni, which again is Uniswap's governance contract or token. And I went through 3 different assets here. First, I started with ETH. And Kyle, I reached out to you for help, but I ran into this really weird issue where the Etherscan source code, which was verified, was not actually the code that I was seeing when I was trying to run this mainnet fork. So then I gave up on that. Then I tried DAI. I couldn't easily figure out how to
Was it a
create
proxy?
arbitrary amounts of DAI. It wasn't a proxy. It might have been that I was several thousand blocks back, but I don't think it was that because this is like something that wouldn't have changed in that few blocks. I think I just did something dumb, but I'm just sharing all this for being the next guide. I'll make this code available to y'all, but like I found that USDC, I could actually take control by impersonating accounts and minting. And a lot of these systems I couldn't take control of easily because you have the Uni or you have the, let's say, what was the other one I tried? You have the Uni contract, and the Uni contract is able to mint tokens, but you can only mint them if you are the admin. And then it turns out the admin is a time lock. And the only one who can submit to the time lock is the governance contract. So I'd have to go through and make a proposal, get all the votes, like all this stuff. And I think this is going to be true for a lot of these tokens that are any of them that have a DAO structure. Even with mainnet forking, they're not easy to take control over and mint.
I have a
Maybe
question.
there's a better way to do it.
Can you impersonate a contract address instead of an EOA, or is that?
I don't think so. So I didn't try, and now I'm going to feel dumb if I try this later and it does work.
Is there a,
But-
you can simulate state? You can go like modify state for certain things. Is there an equivalent for this?
So I did that as well. I have this line here. So check this out. So Compound has a price oracle, which is Chainlink, ultimately leads down to Chainlink. And I did not want to get into the crazy world of Chainlink. So I just wrote this simple fake price feed contract, which just lets me set a price and then get the price. And this is the function that actually exists on the real Compound price oracle. And then I use this other fancy hard hat command called set code, where you give it a contract address. Actually, it doesn't even have to be a contract address. It's just any address. And then you set the deployed bytecode of the compiled contract at that address. And I thought I was really clever. And then I tried to run my short and it failed for some reason. And I couldn't figure out why it was failing. So actually I cheated a little bit and I just skipped that part, as you'll see. But yeah, this was very useful for going through and just learning how this all works. And after doing this, I think the only way to really get this stuff is to do it yourself.
So I think one other command I saw earlier was there is a set storage at in the head. So you
Yeah.
can modify the state, but you have to figure out like which thing to modify. But that might
Yeah.
be easier than creating a proposal, maybe. It depends on the
Yeah.
state.
Great suggestion. And a current student in Block 5 suggested that as well. And I was like, oh, that would have been good. But sadly, I heard that 2 hours before this talk. And the hard part is it's not just like a straight storage variable, which would be easy to
Yeah.
find the slot for. It's a mapping. And I am not familiar enough with that system of K hashing the key. Kyle, do you know, is that easy to do? Is that easy to figure out?
Yeah, there is a fixed algo, right? Sorry, go ahead.
No, for sure. This is related to the thing I was asking you the other day when I was talking about a tool we should make or looking at contract storage. And I was like, yeah, but for mappings, you're going to need to solve that. So
We should build that. I should really just like read the ABI from Etherscan, figure out what the mappings and the function selectors are, and just do it all from there. It seems like it could be done. That was a big tangent there, but I did all that because I wanted to show you some of the fancy tools that I used. And I also wanted to impress on you that actually sitting here and writing this out is why I learned most of this stuff. And so for the future ones, future cycles, I would definitely encourage you, sit down, go and look at one of the smart contract videos, the smart contract programmer videos where he walks through how to do something and then just try to implement it yourself. That was very helpful for me.
gotta say, Melville, it is so confusing how humble yet capable you are. Anthony silently laughing over there.
Yeah, I'm constantly impressed. Y'all don't know because you only see what's presented, but this happens like off camera also all day. I get the same from Kyle and Gilbert, the same vibes.
Yeah. Okay, I don't think we'll be able to go through all this, but let's give it a try. So the way I'd like to do this is, what are we doing? Oh, sorry, this one. But yeah, I took notes down of all the problems that I faced. There were probably more.
Gotta say,
Okay.
that's some nice hard hat tooling that's available. How do you feel about Foundry's ability to compete with that and how long it's going to take to catch up, how much investment has already been made in hard hat?
Yeah, I don't know enough about Foundry. I just know that they don't have coverage yet, but they do have mainnet forking and gas reports. And they do work with Slither now. I think the next one I'll try to do Foundry, but I knew it would just be twice as hard if I did it with Foundry. Like I said, the idea here is we're going to try to go through these 6 steps, ideally ending in profit. And we're trying to short uni. And so we're going to use USDC as our collateral. I basically just set up all the contracts we're going to interact with. There's the 2 C tokens. So think of these as like LP tokens for Compound. And then there's the actual ERC20 tokens. And maybe it's useful to look at the constructor here, but the constructor is also pretty straightforward. Only thing here maybe new is enter markets, which we talked about when we were talking about the subgraphs, because the enter markets is where you actually like specify, okay, I want this asset to be part of my portfolio calculation and part of the liquidity that you're going to allot to me, which is going to enable me to borrow. If you don't call these enter markets, I think you just straight up can't even supply ETH or supply assets to the protocol. But I know you definitely need to do this or else you won't be able to borrow any. Okay, so what happens in supplying is pretty straightforward. In these 2 function calls, I'm just transferring USDC from the caller, who I called Alice, and I'm holding the funds in this compound short contract. And then we just call mint right here. And then with compound, it's got this quirky error checking. So we always need to check if the error is 0. It's Unix style errors. 0 means success. Non-zero means something went wrong.
Yeah, I was flipped by that when I was reading the code.
Yeah, I definitely made that same mistake. I started like that, and I wasted some time. So when we run that, there's only one console.log statement there, but the USDC balance is transferred in, and we're starting with 500 USDC. So let's cancel out this. And we need to get the borrow amount. So this is the amount that we can borrow. Let's look at it here. This is going to end up returning the amount we can borrow, but it's not the max amount. That's the borrow amount limit here. But instead, I multiplied it by 3/4 because, again, I didn't want to borrow at the max limit because I wouldn't get liquidated because I'm just on my local machine, but I wanted to simulate actually being in a real environment where you could get liquidated. And the main functions here are this get account liquidity. This is a pretty powerful function because it returns 2 important things. This liquidity is like the amount that you can use. I'm maybe going to get this wrong. It takes into account things like the collateral factor and the amount of USDC you've supplied and the liquidation incentive. It takes into account everything. And so these two values right here basically represent like, you can use this amount to borrow. And if this number ever goes to 0, which means this number is going to start not being 0, but going to be non-zero, it's going to be positive, that means you're going to get liquidated. Whenever this value is non-zero, it means you can be liquidated. We get the price here from the price feed, and it always returns us scaled by 1E18. Anyone know why that is? Why are we just complicating things so much by adding a bunch of zeros?
You mean in general?
Yep, in general. Actually, I did this in the options protocol.
There just aren't decimals in Solidity, right? So like
So
adding a lot of zeros or decimal places and then managing the divisions that way is the best you can do.
It's for display purposes. It's because there are no decimals in Solidity. And if you want to display like a decimal, then you divide it by this number. It's the same thing that Avi said.
Cool. That makes sense. It confuses me still because like in the end, so you do a series of arithmetic pluses and minuses and multiplications and divisions. And then in the end, you end up with a scaled value, but you still need to work with that value in its non-scaled form. Don't you eventually have to go out of the scaled version and go back to 8? Like uni is worth $8. It's not worth 8 times 10 to the 18.
that's like how precise you want to be. That's what at end of the day, that's what it is. I think that's why the compound is saying we're just going to be precise up to 8 decimals and not full 18.
I understand exactly what the question applies to, but this is generalized to basically how any asset's working, it's just saying they expect up to 18 decimal points of precision to be needed, which is the standard. So just operate as if you have that many points of precision, which for like you will.
I'm going to stop here because I don't want to set the precedence for having to go over and just have the uncertainty in scheduling and timing. I'm going to share this code in the Discord and everyone can go and run it and go through it themselves. I think it'll be a review for some people because we all looked at various parts of the compound protocol.
If we were good, which some of us may not have.
So to be clear, it would be crazy for me to think that everyone's going to go into the same intensity that I went. In fact, I would expect it to be like any other online community where 90% of people are lurkers and there's a smaller group who actually go in. Obviously, like in an ideal world, we don't want that, but that's just how it is. People have lives and stuff. I don't know. That's my thoughts on it.
Super excellent. Well done, man. That is some big shoes to fill you just created as far as president. First of all, Anthony, did you do the charts for him? Those were so clean and well organized. I was like, this looks like Anthony.
They were inspired by Anthony.
You prepare it like lecture, Mel. Now I feel intimidated. If I
just heads out to buy
Really intimidated. If anybody wants to contribute,
the Melville bar.